Okay, 10 seconds to the contest. Let's go. Alright, let's go. Oops, just for the creation of a file. Okay, easy. There are cities, print and lines, let the number of cities directly connected and those cities in ascending order. Alright. Are they bidirectional graphs? Probably. Passes, samples, let's go. Okay, we got accepted, non-judging B. You're given permutation where, okay, this is not the same, assume that base k lexicographical smallest among permutation, find the k minus 1 lexicographical smallest. So the k minus 1 lexicographical smallest is like previous permutation, right? So does previous permutation even exist? Or do you need to swap? So what do you swap? You swap the k minus 1th permutation. So how do you do this? Can do this, k minus 1 permutation. Can you reorder the elements and do next permutation on the permutation of permutation? Well, just to see what the standings. Reorder the elements. So the inverse of the permutation. Actually, we don't want the inverse. The inverse plus 1 inverse that. Is that correct? Let's see. Of the inverse permutation of this will be is that correct though? Or is it some brute force? Here swaps 1 and 7, here swaps all the numbers. Is the previous permutation? Does such thing exist? It does exist? Alright. Accepted. B, D. Given a sequence of positive integers, you can choose and perform one of the following operations, ending possibly 0. Choose an integer, multiple of 2, and divide it. Your objective is to make A satisfy this equal. Find the minimum total number of times you need to perform the operation. Alright, isn't this the sum of the... Alright, so what is this number that it ends in? Because if we know this number that ends in, this number will be equal to the okay, so we get all of the all of them. Okay, let's do this. Let's see, and the factorization of the number. So and we want to do this int factors of an, and this is going to be like 2 factors here. So while AI is divisible by 2, AI, we don't need anything else, right? AI factors at I at 2 to 0 at plus plus, and this is if it is divisible by 3 and 1, and then I want to sum up. Okay, so we kind of need to remember that. Need to remember what is the last number. Okay, we have the last numbers, and now how many times should I multiply getting some numbers. So okay, 2 to the p. So AI can be written is 2 to some power times 3 to some power times something else. And now I want to know, can I... Okay, this something else has to be equal in all of them, right? Is that the case? Yes, probably. And now I just need to see what is the maximum power of 2 and the maximum power of 3 I can get. No, not the maximum power, the minimum power. And P2 maximum P max. Or was there a max element? Yeah, so for repetition, max element, factors, repetition, factors, and this P repetition is equal to this, and then okay, so that's the minimum element we need, right? The min. And okay, so the answer is so okay, it's true. If AI is not equal to A0, then okay, it's false. Alright, if it's not, okay, just now. Okay, now answer is the factors at repetition at 1 minus P at repetition. The two factors here. Passes. What else can be? Yeah, nothing can be. There can be 0. I think that should work. Just wait for the judge. Okay, gets accepted. Let's go. Where's the task? Let's go round trip. This is more complicated. Let's see where the standings are at. Okay, this time 14 minutes today. We have grid with these columns. Each square represents an initial point, a road, and an obstacle. Okay, so initial point, road, and an obstacle. Determine whether there is a path of length 4 or greater that visits that starts at the initial point, repeats moving horizontally or vertically without going through an obstacle or visiting the same square multiple times except the beginning or end. Formally determine whether there is an integer this sequence. Alright, so just say yes or no. So if what is exactly the problem now? Or determine whether there is a path of length 4 or greater that starts at the initial point, repeats moving vertically or horizontally and returns to the initial point without going through obstacles. Okay, so if there is a cycle of length 4 or greater, alright, so how do we do this? And these are very... Oh, so like, yeah, okay, the matrix is that big. Okay. So how do we do this efficiently? So we take a DSU and we connect all of these edges that are adjacent, and if something creates a cycle, then the parent edge has a cycle, and if that parent edge has a cycle, so but if something here creates a cycle, we don't want the parent edge to have a cycle as well. So okay, so it's not straight. There is some property with like being at least 4. So what if I divide this vertex into like 4 vertices, and I see, okay, this to here without intersection, or to whatever other without intersection, right? So alright, how do we calculate with path without intersection? Do we just do like BFS everywhere? Would that work? Yeah, just like BFS everywhere from each of these nodes, and then combine the results. Alright, let's do this. So let's do this. Let's say like this, we have some matrix, and N, and then for the initial point, so we find the initial point, we find the initial point, and then we say we go into the 4 directions. Microphone. Okay, we go into the 4 direction. New x is sx plus the x direction. Let's just zoom in for better viewing experience. Direction if it is valid. So I'll just say this now. In x in y, x bigger than 0, y is bigger than 0, and x smaller than n, and y smaller than n. Now, if it is valid, we are going to do BFS on this matrix. This BFS on this matrix is x and sy, right? So okay, so it's gonna return like 3 values. BFS is going to answer that pushback BFS matrix. Alright, like this. Now an answer is going to be a vector of pool. So like I'm just going to say this answer is 0, answer or this, right? So see out answer yes or no. And now only I need to do the BFS function. Bool BFS is going to take into this matrix, is going to take into, and so like x, y, and sy, and then it's going to perform so like q, well q is not empty, so on whatever direction, say also from the first plus the second plus the eval, and then the matrix. Here we need to check as well, and matrix if nxy is like a dot, right? So if that's the case, we can do this. Okay, if it is valid and the new matrix is a dot and is not visited, we say visited nx and y is true. Right, so this x and y is true, then we go and say q dot push x and y, and now I will go through each of the directions. Again, I'm just going to do, okay, let's write it again. So sx plus dx and y is y plus dy diff. This is the same idea here. If valid, and matrix nx and y is a dot, and it is visited, and nx, and now this out of p is np is make pair nx and y. If np is not equal to make pair x and y, so if it's not that position and it is visited, return true. And here I can stop if the answer is not true. Also I return false if none of this makes sense. Okay, this passes samples, I'll just submit it. I think it should be fine. Okay, this is fine, accepted. Let's go double chance. Okay, let's read this. They're in cards, they've written, solve the problem. We have a bag that contains k cards. So that contains the card to the k number. Okay, let us perform the following operation twice and let x and y be numbers recorded in the recorded order. Draw a card randomly at random and record the number written, then return the card into the bag. So okay, print the expected value of maximum of x and y modulo this. Okay, so okay, let's just again see the standings. So at the random, return the card to the back. So actually, like there was the same trick. What is the probability for the maximum of this? There was a trick recording this maximum. Let's see, like this. Let's make some kind of table here. So we have, like, let's say 3 cards, and then how many different ways would we get to? Okay, so let's say 3 cards. So there is, like, we pick if we pick 1 and 1, we get, so there's 9, right? But there's one way we pick each of these, but now in the recorded order. But now the maximum, it doesn't care for it. The maximum here is 1, here it is 2, here it is 3, 2, 3, here it is 2, here it is 3. So this is the table we want to generate. So I'm assuming this table just continues downwards. So, like, assuming we can prove now by induction. So this is the table. Now we can say that here when you add, you always add, how much do you add? You add 2 times the width, so you add 2 times p minus 1 plus 1 of the new cards. That's the probability of getting the new cards, the new card over the probability to get the new, so p over p squared, right? Okay, let's see. Integer a I've written on it. So like this problem is, it has an integer AI written on this card. So you have an AI written, but AI also goes to this here. It's not just numbers. You pick these two numbers and you see the maximum between these two cards. So when I add an AI, what happens to the cards? So okay, let's say I have this. If I add 4 here, what happens to the cards? I add 4, like, it doesn't matter, it just matters if it is sorted. So print the expected value of the maximum function. So the expected value of the maximum function is for all of the maximum is wait, what? Wait, can I just see the other quickly? Okay, find the number of sequences with integers n satisfy this is to m, so each of them is to m. For this, the remainder is divided. Remainder when a is divided is different from the remainder. This is different. That's so wait. Okay, that doesn't sound like a bad problem. How many positions? So we have, like, okay, to these, like, there are 3 positions here, right? Then for the next integer, there are only we can pick any of these integers. So in fact, we need to know how many integers have remainder by 1 modulo this, remainder by 2 modulo this, and remainder by 3 modulo this. And then we can rotate them, right? Oh, but there is the constraint of this So all right, so there is the constraint of this. Sequence has to be 10 to the 7 is probably because you don't want to use some secretary. Interesting task. Construct a matrix. Determine whether there is an n by n matrix X that satisfies the following condition. Present such one matrix. is 1 to 3 and holds that the product let P so like there's EI for each row, I'm assuming. No. For each square, nice. So for each square, the product is congruent to EI module 3. The product. How would you represent the product? Thinking like, yeah, there's no way to represent it in a graph because it's too big, but the constraints are such that what falls to the product? To the product falls if okay, I'm not sure about this one. Okay. Okay, let's see double chance. Let's solve this. So pick at random what is the expected value of the max function of two integers that we. Okay, so let's say we have fixed number of cards. Then we're going to use probably some DP to go to the next card, but let's say we have fixed number of cards. What will be the maximum value among, like the expected maximum of this? So the expected maximum value is going to be, okay, so for this, for let's say instead of 1, okay, we're going to have AI here, right? So it doesn't matter if we sort them. We know what is the expected value of the smallest, we know what is the expected value of this, we know of this, and then the expected value of all is just the what is the expected value of all? Like there are that many times to get this card. So the expected value of all is AI times the how many times this. So this is the expected value of this when AI is sorted. So can we do some kind of segment? No. So how do you add a card then? It must be like a segment tree, right? On AI. So like on AI is a segment tree, but how do you calculate the value upwards? Is okay, we have this. When a card is added, it changes the sum to how many values to all of the right of the tree, because all of these here will get a bigger P. So like if I add a card here, these all numbers will get a bigger P. P minus 1 times. No, it's okay, we're going to rewrite this as like this. Okay, the index of this card is 1, Then we say, okay, 2 times the index of the card divided by the number of cards squared, right? So yes. Okay, 2 times the index minus 1 plus 1 divided by the number of cards squared. So this number of cards squared can be then put an outside, right? So we know is the answer is times 1 over n squared. So essentially we have this, right, for each card. And when I put a card in, can I calculate this for the trick here is, okay, so this as well, I can put the one here. So let's do this plus 2 minus 1 times AI, right? So I can take care of this, but I need to take care of this now. And how do I do that? When this changes, all of these cards I should add 2 times. What should I add to the tree here on this card? When I add like a card here, okay, when I add card, nothing changes for the previous set of cards, but for the other set it changes. For cards bigger than itself. Cards bigger than itself. Okay, 2 is a constant, but it changes the index. So it adds for each, it adds AI. So for cards bigger than itself, I want to add AI here. So essentially, I want the sum of the bigger cards than this. I want, and I put this card here. This is it. This is all I want, right? Isn't this correct? Isn't all I want this? The sum of the cards? Yeah, let's try coding this type of solution. We'll see what we are missing. It's definitely like some kind of sec-tree, but let's see. Sec-tree. Okay, then I want mod int. Then I want to need to type def here instead of doing this. Alright, so mod int here, instead of this I will have like the value is essentially mod. Essentially I don't need a mod int. I can live with integer here. But I need modular arithmetic to get it working. And I need to make the tree buildable, because this tree is not buildable. I need to update my snippet here. I need to call build, each time I going to the recursion, and then when I set here, I'll set the value is equal to v at L, the left position. Now the tree is buildable. Now I can have like an array here. I can say like this, and I can say segment tree. Essentially, I don't need it to be buildable. What am I doing? I'm going to build the tree. Segment tree. I just want the sum on the end edge. So like, okay. Actually, a fanfic will do the job, but whatever. So okay, what is now the size here? Okay, the answer at, so I'm going to say it like this. Okay, answer. The answer needs to be divided by how many elements I have squared. Like this. Needs to divide this. Then I will just see out the answer. Okay, so the answer we set, it's what we got to this point. So yes, this is the diagonal. So I'm going to say, okay, I will have like some modular integer here, and I will say this is the sum, and I will say sum plus equal a of I, and then answer is the sum. And then I need one more thing here. I don't. It's lazy secretary, do I? No, I don't need lazy secretary. I need. This is prefix, but then I need sum. And then, okay, prefix, and then the sum is going to be whatever the answer is here at this point. And before I update the sum, I need to add, what do I need to add? I need to query the tree, to query how many from node A I. What if they are the same nodes? What happens here? Nothing really, right? Nothing really? What happens if they're the same? Yeah, it depends where you put it. It depends in the tree where you put it. What is the number of nodes which are in front? So let's do another fanfic. really don't need long longs here, just don't waste memory. But I think I have 1 gigabyte of memory, so alright. Let's see like this. If vt is going to be both of them are going to be max ins, and you're going to say constant max n is 2 to the 5 plus whatever. And I'm going to say, okay, so how many in front? In front is fvt dot ai, and I dot get fvt and I, then I ask for this to the max n, and then in this is the to add that much to the answer is actually times 2. You need to add that much to the answer, and now you need to add, essentially you need to add what do I need to add now to the answer? This is complicated. Okay, I query, so I have like this, and I want to insert here a 3. I query all of the elements, including this 3 here, and I say, okay, these elements don't change. But the 3 now gets this position where these elements are, so 5. So is it 5 times this? No, it's minus 1. So, okay, in front is this. So 3 gets, in front times minus 1 times 2 minus 1. This is what the 3 gets now. And the to add is, okay, actually like this, right? The prefix already actually the sum gets it, so it's fine. Yeah. So the sum gets it. But actually you need to add, what else you need to add? You need to add this to add this value, you need to add it. You need to query this. Oh, so like 2 times 1, but 1 is over 2 times 1, and then actually this is fine, right? Okay, when I add 5, what happens here? I add to the prefix. To add has nothing, 0. In front is 0, minus 1, minus 2. Wait. this is not correct here. How many elements are in front here? If there's no element, what happens if there's no element here? Should add 0 here. If there's no element, this is 0 plus 1. This is plus 1 or minus 1. Zero minus 1 minus 2 plus 1 minus 1. To add is 0. Alright, so that's not correct. So what we add, if here is 0 elements in front, we don't add minus 1 here, we add in front times this. But now, wait, there are 2 elements in front. Times AI. Then something like this. Let's try to fix this. So the answer will always be divided by how many elements we have right now, right? Squared. So yeah, that's 5777. How many? There's 13 divided by 4. Okay, divide by 2. Yeah, square. So that's correct. That here, adding this sum, wait, now this sum is here, but yet we're not doing anything with it here. What are we doing though? What is the transition when we add them? So we say, okay, in front there are, okay, some in front elements, right? Then we say, okay, get me every element from the next to this, and for each of these elements I need to add, for each of these elements I need to add, so for each of these elements I will have to add plus their sum. So I need to get their value times 2 is like offsetting them, because what happens if I add here a 2, this here gets like, okay, 2, 2, right? Oh, so wait, plus 1 element, because this is 1, 2, 3, 4, 5, 3, 4. Wait, this moves. Y times 2 though. What we have, y times 2 okay, let's see to add is, okay, the value of all of these oh, so this let's so times 2. Okay, let's say we add all these here, we add for each of them, right? Is that correct? Yes, that is correct. Answer is, so we add in front times 2 times this. So the answer, we add this here, right? We add to the answer like all of these. We shift them. Wait, what about the fanfic tree? We never update the tree now, nor the fanfic tree. When we put into the tree, we want to sum up. I even have no idea what is this module. Okay, what about without division? Without division, it turns out to be 21. We need 26. It needs to be 26. And then when we divide by 4 square, 4, divide by 4, then it's gonna be alright. But what am I missing here? Missing the 5 somehow. Missing the 7 here. 5 times there's 1 in front, so 2, 1 times, okay, that's okay. So to add should be 0, right? Default is 0. Do I need to add on this? You need to add to prefix it. Oh, what is going on here? What is going on? Wait, what? Excuse me? Oh, wow. This isn't what I wanted to do. Probably. Wait, should I add it to the sum? Wait, what should be the expected total though? If it's like sum only, what do we gain? We gain 2, we gain 21, then we gain 22. Okay, then 22 is not correct. Actually, it is. Well, the 7 moves backwards. 15 plus 7, 22. That makes sense. Plus 21, 3 sevens. Let's just draw the table so you guys can. So there's 5, 5, 5, 5, 7, 7, 7, 7, 7. No, and then you had this here plus this is 22. You had these here. Oh, now you add. You plus 2 is here. It's not plus 1. It's like plus 2. No, not here. The value to be added is the sum of this times 2. No? This now should be correct. Okay, passes. So if it passes samples, we know that it is pretty much correct. But we took a lot of time debugging. I should have drawn just this table and that would have been it. But whatever. Alright, accepted. Okay, so we're probably very low on the standings, but whatever. Let's see G. I don't know, like here, because you need to know how many integers have been passed, I think it's some kind of prefixes. But still, can it be a matrix multiplication? Matrix exponentiation. But I don't see how I can remember how many. How about some like polynomial multiplication? Like, is there a chance here to be like polynomial? Okay, so let's take a look at these sequences here. When m is too big, right? But what do we know? What do we know about m? So let's say first like the naive approach, you know? So this is the dp here table, and then the next dp table is like for each here m, I can pick any here from the dp which are which do not share the same remainder. So like I can pick any of these for each of these integers. So could it be some interesting polynomial? Like essentially it's like modular thing here. Because this repeats. First is like genera is the first two, and then the Essentially, how would you write this? This you would write as f of, let's say that this is position I, and this here is position, this here is position P, let's say. Okay, so IFIP is essentially the sum, but here there's module. How do I write this mathematically? Okay, the sum from what? From what? Okay, the sum x. So yeah, okay, I will write it like this. Yeah, let's try this. Okay, f of I x. So where like x is some whatever, that doesn't matter. Like it's for now we're converting it to a polynomial, but it doesn't really matter. And this position, so I, is so something at f of I minus 1. And now here with the axis, what I want is like to shift twice here. So like x, is it x squared here inside the polynomial? So if I evaluate it at x squared, is that true? No, that's not true. It's like I want to shift it by x, so I don't want to evaluate it. Essentially, I want the coefficients of, so let's write this like this. One a3 x2, so forth. I want now the new polynomial to, here at the 0 we're not gonna do anything, but here at the 1 I want to take this and the other one. So I want actually to shift this polynomial by x. So I want to shift f of x times x plus f of x times x squared. So shift it twice, essentially, right? So essentially what I want is, yeah, so this is what I want. I want to shift it twice. And okay, so how do we quickly calculate this? Because now this is the new f. Let's say this is f2, right? This is f1. So you have some kind of polynomial. So f2 can be also written as x times f1 plus f1 times x or something. Also f1 can be, but what does this help us really, or does it solve the problem? Times f of x1 times, and now this is like 1 plus x. Oh, now we're getting somewhere. So essentially you are multiplying the old polynomial by x and 1 plus x. Is that correct? So is it just that straight? Wait, but I can't multiply by x and by 1 plus x. Well, because of this recursion, how do we take down this recursion though? Like matrix exponentiation, but Even matrix exponentiation, how many steps would it require? These polynomials are huge, so how many seconds do we have? We have 4 seconds. And 18 minutes to solve such a complex problem. But if that's the case, like the recursion will sound what? Oh, we can't really do that. So like multiplying the polynomial again and again and again and again and again. What will take this n times m log square n, something. Yeah, I don't think that's fast enough. But probably if you like do this and you see what the coefficients do, then you can probably create some combinatorial formula with that is fast enough to solve this problem. But wait. Can't we just? Okay, we have this polynomial, but this is 1, right? And then we multiply again with only this, right? But how do we log for m? Okay, let's. How do we log for m though? Yeah, I think that's the solution. Something like that is the solution. So this polynomial here we have is essentially what? X plus x squared, right? So essentially 0, 1, 1, right? I'm just gonna go code it. And we have entity. Okay, we have entity. We need modular, and I'm just gonna go code it and see if anything does work. Maybe not, doesn't work for the hell. Time def long, and then we say okay int m, and then we create like. Is it though going to be fast enough? For each n, we want to push back. Wait. We can do exponentiation, right? This to the exponent. This to x. But no, we still have to. Let's try this. primitive root. That's the sum of all. Wait, what? Is it the sum of all? No, apparently not. Yeah, there is a sum to m, right? Whatever. That's the same, whatever. No, this is not it. The sum to n is n, and m's 4. This doesn't make sense. No, like it doesn't make sense. All of these have to be smaller than n, so like multiplication, 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 and then the remainder ai is divided by different remainders. Okay, but it's 2m, so there has to be 2m's. So again it's 0 0. So to m there is 1. Oh, but we start with a polynomial which is different. We start with a polynomial which is okay, we start with a polynomial which is like 1 1 1, right? Something like that. Wait, what is the p now for auto element? Try to solve this. Do we start with 1 1 1? And what is m4? No, we start with 1 1. Oh, plus this polynomial, right? So plus itself, right? Plus f of x. Isn't this correct? Okay, plus f of x doesn't change anything. Actually, yeah, it can. Okay, I see why this doesn't work. We cannot just change. We need to shift it by one. We need to shift it again by one. Okay. To get both of these two. But we also want to get like yeah. It's what I wrote at the beginning. It's much more complicated. It's like sum over f of x times x, let's say k, where k goes through like, so like k is what? K is like 1, 2, and then 3 can't be it here. 0 can't be, 3 can't be. So 4, 5, right? 4, 5. So how do you write this? How do you write this? Like you can write times all of k from like 0 to m, and then like you have times whether or not k is divisible, like it's not divisible by 3, and then do like on top of this the like, but this is impossible to there's too much computations. I don't know. Probably I'll give up. Probably there's some mathematical thing behind this. Matrix doesn't work. Matrix doesn't work. I thought polynomial, like if you would, yeah, polynomials, but no, it will be too slow. It's something about combinatorics. It's something about combinatorics where you actually calculate the ways with some formula. Because you can be shifting, but you can be doing like prefixes on different. Yeah, that could be it. Yeah, just do like prefixes, prefix sum, and then prefix sum on every of these, and then prefix sum on every second and on every third, and then to get this here, you add, yeah, that's probably it, and then you do like, because that maybe not fast enough, you do maybe like matrix exponentiation on that. can we do some kind of this DP? But I don't have time. Like it's the trick is okay. It's all of this. So let's say this is prefix all minus prefix at 0 and then prefix all, like this is for 1 and this is for so this is what? This is the remainder if the remainder is 1, we want prefix all minus prefix at the remainder. So prefix at the remainder is whatever we have here, and then again this add to the remainder, and again all minus whatever we have to the remainder. And like, is this it? And then maybe we need to do like matrix exponentiation just to make it faster. But also all of these update, right? Yeah, all of these update as well. It's not just one update. But do you care about them? You care, right? Because they can be equal, right? Yeah, so you care about them. So we need one more step to figure out how you do this. How you do this without either you have like some other prefix that you, yeah, it doesn't matter. We solved what to f and we had no penalty. So I mean, f we could have solved it way quicker if I just drew the table and I didn't spend time discussing shit. Okay, so constructing a matrix, though this kinda looks like some kind of two-set problem or something, but the product of this is very not clear, because it's interesting. It's you have like a rectangle, and then you say that this product has to be congruent with 3. Is either like a max, it can be max flow because it's like it's too much, and it's too much, and it's too big for any kind of max flow or whatever in this case. But yeah, okay, so this has been it. I'll just go through the tasks. I want to see what is G all about. Okay, here are the conditions. We consider the number of paths regarding this, since the weight of the term independent of the sum. So it's sufficient to consider values. Problem can be solved in of n time. So yeah, so something like that. Okay, so just going prefixes without like. And then what is this? if this or this, there's some set we used to solution to the original if there is a condition with this, the elements covered. Come on, like, problem boils down to simultaneous equations on f2 n square. The system doesn't have solution n square variables. Whoa. Okay. Okay, so Gaussian, bitwise somehow Gaussian. Okay. So it's interesting problem. So let's go and over the contest, and we solved the problems A through F, and just take a look at them and explain them all by here. So okay, so let's start with A. So you're given some string S, and if A appears in the string, you need to print out the last index it appears. Very straightforward problem. We just go through the string, and if we see A, we just update the answer, and then we print out the answer. That's it. Okay. Okay, let's go B, adjacency list. So you're given some n in m m integers, and then you're given some list of connections between between some n cities, right? And then you want to print for each city how many connections are connected to that city, and the connections in ascending order. So essentially we have an adjacency list, and we push into the adjacency list, we create a bidirectional graph, so undirected graph. We sort them, and we say that, okay, for each of the cities, we print how many connections it has, and we print out what are the connections. Straightforward. Previous permutation, I didn't know really about this, how to, I mean, I could try solving it by hand, but it would take time. But there is a function called previous permutation, and what it does, if you call it on some array which is zero indexed, so the permutation in the array is zero based, it will find the previous permutation of this array. So yeah, you just call previous permutation, and then you just print it out. Okay, so that's C. D is you're given some array, and you can perform the following operations any number of times, possibly zero. So possibly you don't have to perform them. Okay, so you choose some integer in this array, so some element, and if it is a multiple of 2, you replace it by the division, and if it is a multiple of 3, you replace it by the division by 3. And then your objective is to make the array equal. So the first the thing you have to see is just that, like, every number can be factorized to like powers of 2 times powers of 3 times some other number, and these other numbers have to be equal in order to, just when you divide this here, whatever is left, it has to be equal. And plus, you will make you need to divide all of the numbers by the minimum respectively in like the powers of 2 and the powers of 3. Because if some number has like some minimum power of 2, let's say 3, 2 to the 3, and all other numbers have 2 to the 10, 2 to the 20, 2 to the 12, whatever, you have to get all of them to 2 to the 3, to the minimum power of 2. So essentially you essentially you bring all of them down to the minimum, right? And this is exactly what I do. And essentially I have the factors, and this is the two-dimensional array, so it has like two separate arrays where in each of them I see what are the powers of 2, what are the so how many are the powers of 2, so how the exponent in the 2, no, how is how big it is, right? So I divide by 2, I divide by 3, and I check if all of them after the division are equal. So all elements of AI have to be equal. If they're not equal, I can just return false. I can return -1. But if these mi here are equal, then I need to bring down the powers. So the powers are, I just say like, okay, I get like 2 minimums, and I get for the 2 factors, I get the minimum elements, and then I add to the answer how much this element, how big. So if I have here 10 and I want to get it to 3, so I add 10 minus 3, and then 20 minus 3, and then 12 minus 3. All of these I add to the answer, and I just print the answer, and that's it. E is an interesting problem. So essentially you are given some matrix, and then you have this starting position, and you want to move to some so you want to make cycle some path such that it never intercepts itself, and goes out of S and comes back into S. And you want to say, okay, does such path exist? So, but never like intersecting, and just like going out and intersecting back just at S, just the position of S at this position. So it is very, very obvious to see that you just need to take a look at the 4 corners, the 4 adjacent squares to this position of S. So if S is here, I just need to take a look at these 4 corners. And at each corner, I will push a BFS. So I will start a BFS here, and then this BFS will go through the graph, and if it reaches some other corner, then I know that there is a nice path here. But if it doesn't reach, I know that wherever I start here, I will never reach the other corner. I maybe reach the same corner, but that I don't care, right? Like whatever. And I do this for all corners, and then I check if some other corner except this one is reached. If it is reached, then I know that there is a path, and I can even print the length of the path, but whatever. So the code is a little bit more like it's bigger, but it's nothing. It's really just BFS. You take position S where it is, and you go for all of the directions in S. You push BFS here, and if BFS returns at any direction, okay, then like you can just stop the algorithm. And you start at some adjacent square to S, and you want to know what S is, so you don't go there. So you check the other square as well, right, around S. And then you just keep a visited matrix, and then you just perform simple BFS, what is like to the visited. And you then check around all of the 4 corners at S, except the corner where we started. And if we are visited at that corner, then we return true. And that's it. That's the whole problem. Quite an easy one. Oops. So double chance. Double chance is a little bit of a. I mean, it's not a hard problem. It just have to see a lot of things, and you can get easily confused by something. And I didn't draw this matrix at first. Like, I didn't draw this matrix at first to just understand what happens in the first case. I draw my own matrix, but okay. So it's a little bit harder to explain. Let's go here. So the idea behind this problem is the way that like, when you have some like two integers, and okay, so first, what is the problem? So the problem, if you know, just skip it. But just what is the problem? So let's say you have k cards, and each card has some integer written on it, and then you get a card out of the bag, you write down what integer you got, and then you put the card back. And then you get another card. So what it says, it just randomly pick a card, write it, pick another card, and write it. Right? So these could be the same card. Okay? And then it asks us for the expected value of the maximum of these two cards. So what will you get as a maximum of these two cards? And now if I have just a fixed number of cards, let's say I have 3 cards, and the cards are just like, let's say 3, 5, and 10. Okay, so the maximum between these, if I pick 3 and 3, so I pick once 3 and then put it back, and I pick 3 again and I put it back. So the maximum is 3. If anywhere I pick 5, so I pick 3 and 5, or 5 and 5, I get 5. And then with 10 is the same. So anywhere I pick 10, I get 10 as the maximum. Okay, and then you can quite easily see that this has some pattern here. And okay, so the solution is quite simple. Essentially, is now you know how to calculate this pattern, right? But the problem is, how do you, when I now add another card, let's say 7, how do you put this 7 here? So what does this 7 contribute here to the expected value? And how this 10 here will get more 10s here? So these 10s will be more here. There will be 2 more 10s here, right? Because this extends. So the array will be something like this, right? So now 7 will have this number of 7s, and 10 will have more 10s here, and these will remain 5. And now what is the expected value? The expected value of such a configuration is essentially I can write it here in blue or whatever. The expected value of such a configuration is essentially the sum like this. Yeah, the sum over all integers, over all of the AI, right? So all the AI times how much this AI contributes, how much this AI has here, right? So the AI here in the sorted array, so it's sorted, AI here has exactly 2 times I plus 1 divided by n squared. So what this means, like this here, if it's 0th index, it has 0 times 2 or here in 1, I will say. Okay, 1 times 2, so it has times 2 plus 1, so that's 3 integers divided by n squared, divided by this whole grid. This is how much this contributes times whatever that is written on that card. Okay, but now we can rewrite this, right? We can rewrite this by saying, by getting n squared out of the answer and saying that this is equal to this. And now we just need, when we put another card in here, we just need to keep track what will change for all of these cards. So how much will it change? And when we put this card, we need to know on what position did we put this card. So we put it here on the second position. So here is 0, here it is 0, 1, 2, right? So this card here, when we put 7 in, we put it on the second position. So essentially, it's just mathematics. Essentially, in front is how many cards are in front. With how much is now this card contributes to the answer. We add also the cards that are bigger than this. All of these cards get times 2 by their value. Because this 10 here, this 10 was here. Now we'll go here, and these will go like this, and now 2 spaces here will be created for other 10s. So essentially, you add this as well to the answer, and then you prefix sum it, and then you see the answer essentially is the sum divided by whatever now the state is. How many cards are there? And because we use modular arithmetic and the modulo is is prime, we can do the inverse operation essentially to get division, right? And that's pretty much it. And then I forgot to add them back into the tree. But yeah, that's what you need to do, like to add inside the fanfic and inside the segment. You can do this with like one segment tree, but or you can do it with 2 fanfics. But whatever. I used segment tree for the end, and I used fanfic for the prefixes. Yeah, that's pretty much it. G I didn't solve it, but as it seems, it's just prefixing. So like whatever this position is, minus whatever, prefix it like these positions. It's just like the tutorial will probably explain it well. I'm not going to take a look at now because now it's starting a new contest. So thanks for watching, and I see you later.